Welcome to this video in which we will see preparation of acetate buffer with pH 5, concentration 0.1 molar and volume 100 ml. So buffers, these are the solutions which resist the change in pH. They are used to maintain pH in different systems, which is required to carry out enzymatic activity and to maintain the pH during the growth of the microbial cultures also. So acetate buffer, acetic acid is a weak acid and its salts with strong base like NaOH, KOH. These two mixtures can act as a buffer. So the equation which is used for doing the calculation is Henderson-Hasselbalch equation, which is pH is equal to pK plus log of dP by P. dP is deprotonated species and P is protonated species. Deprotonated, that means species which is having one proton less, and protonated means proton is present in that particular species. So here CH3COO minus is dP and CH3COOH acetic acid is P. Sodium acetate, since it is a salt with strong base NaOH, it also dissociates as CH3COO minus and Na plus, and which leads to formation of deprotonated species. So as per the equation, pH is equal to pK plus log of dP by P. So we want a buffer with pH 5. So put pH 5, pK of acetic acid is 4.76. So putting that value in the equation, 5 is equal to 4.76 plus log of dP by P. So 5 minus 4.76 is equal to log of dP by P. So 0.24 is equal to log of dP by P. So if you take antilog from both the sides, antilog of 0.24 is equal to dP by P. Since the antilog and log functions are opposite, that will get cancelled from the right hand side. So antilog of 0.24 is 1.73. So ratio of dP by P is 1.73. So here from this equation you will understand that pH decides, since pK is the constant, log is also a function which is constant, pH decides the ratio of dP by P, or in other words, ratio of dP and P decides the pH of the buffer. So the ratio for pH 5 that we had obtained is 1.73. So 1.73 can be written as 1.73 as to 1. So if you mix dP and P in a proportion of 1.73 as to 1, you will get pH equal to 5. So for dP, the total volume, if you mix 1.73 and 1 ml, the total volume will be 2.73 ml. In that, dP will be 1.73. So for 100 ml, you will do the cross multiplication and the volume that you will obtain is 63.36 ml. So dP, which is sodium acetate or acetate molecules, the volume that you have calculated is 63.36 ml. Similarly for P, in 2.73 ml you have 1 ml of P, and that's why for 100 ml, if you do the cross multiplication, the answer is 36.63 ml. So if you prepare 0.1 molar solutions of sodium acetate and acetic acid, and if you take 63.36 ml of sodium acetate and 36.63 ml of acetic acid, the total volume will be 100 ml. Since both the solutions you have taken 0.1 molar, the final concentration of the solution will be again 0.1 molar. And since you have done the calculated the proportion for pH 5 and you are mixing in that proportion, the pH that you will get is 5. So in this way you can prepare acetate buffer with pH 5 by using 0.1 molar sodium acetate and 0.1 molar acetic acid.